Hi, in this video we're going to learn how to solve problem 1.4 in the Griffiths and Shroeter Introduction to Quantum Mechanics 3rd edition textbook. Problem 1.4a asks us to normalize this wave function, which is described by this piecewise function. And in order to do that, we have to find this constant big A. We can use the relationship where the integral from negative infinity to infinity of the complex conjugate of the wave function times the wave function with respect to dx must equal 1. This is because this here is a probability density, and integrating the probability density from negative infinity to infinity must equal 1. So we could substitute the values in. So on the interval from 0 to a, the wave function is ax over a. And then from the interval from a to b, it is a b minus x, b minus a, and if you notice, the complex conjugate of the wave function is the same as just the normal wave function. So then now all of this will be equal to this. And if you notice also, the bounds is not from negative infinity to infinity anymore, but it's from 0 to a and then a to b. And this is because outside of these intervals, the wave function is 0. So the integral will always come out to 0 for those. So now we could just solve for the integral from 0 to a of a squared x squared over a squared. And we could just do normal integration with this one. This will come out to a squared x cubed over a squared over 3, 0 to a. And then what happens here is we don't have to worry about this 0 because this entire thing goes to 0. And we just get a squared a cubed over a squared 3, which is equal to a squared a over 3. And then now we could do from a to b. And we use u sub for this, which will be u is equal to b minus x du dx is equal to -1. And the initial will now be b minus a because we just have to plug in the first variable for x, and then the final will be 0. So we substitute everything in. And then now we just integrate like normal. And here we don't have to worry about the 0 because this entire function will go to 0. And we just have to worry about b minus a. And then what we get is a squared b minus a cubed over b minus a squared 3, which is just a squared b minus a over 3. And if you notice, the negative goes away since the b minus a is on the bottom. Okay, now we just have to combine all of this. So we know that a squared a over 3 plus a squared b minus a over 3 must equal to 1. But if we simplify this, what we get is a squared. And if you notice, this a squared, a will cancel out with this a squared a once we distribute the a squared in. So we just had a squared b over 3 is equal to 1. So we know that a squared is equal to 3 over b. That means that a must equal the square root of 3 over b. Problem 1.4b asks us to graph the wave function with respect to x. And outside of the intervals from 0 to b, we don't need to worry about what the wave function will be because the wave function is just 0. So let's say that a is right here and then b is right here. So the function that describes the interval from 0 to a is just a linear function with respect to x. And the slope of this linear function is the square root of 3 over b, 1 over a. And then now from the interval from a to b, it is also a linear function with respect to x. And it will just go all the way down until it reaches b. And this slope is equal to negative square root 3 over b of 1 b minus a. This is because we just have to distribute this value in, which is square root of 3 over b, as well as b minus a into x, and just see what is multiplied by x, which is this value here. And the peak of this graph will just be what we substitute in for a. After we substitute in a for x here, and what that is just the square root of 3 over b. And the same thing happens as well for this function, because once we substitute in for x for a, what we get is square root of 3 over b, b minus a over b minus a, which is just the square root of 3 over b. So we see that this is a continuous function, which is necessary for a wave function to be satisfied. Problem 1.4c asks us what the highest probability for finding the particle at t equals to 0, and this wave function is given at t is equal to 0, and the answer is x is equal to a. And this is because the wave function as well as the probability density peaks at x is equal to a. Problem 1.4d asks us to find the probability of finding the particle to the left side of a. And what we need to do is find the probability of the probability density of the wave function and then integrate to the left side of a. It also asks us to find that same probability when b is equal to a and then b is equal to 2a. So this is the equivalent of finding the probability from 0 to a, because when x is less than 0, the wave function is 0 anyway. So the integral from 0 to a of the complex conjugate of the wave function times the wave function is square root of 3 over b x over a, square root of 3 over b x over a dx, which is equal to 3 over b x squared over a squared dx. And then now we just integrate this like normal, and what we get is 3x cubed over ba squared over 3 from 0 to a. And this is the same thing, since these three cancel, of x cubed a squared b. And then now we don't have to worry about 0 because this function will just go to 0. And then now we just have to worry about a. And then when we plug in for a, we just get a over b. So in the case where b is equal to a, the probability is equal to just a over a, which is 1. And in the case where b is equal to 2a, the probability of finding the particles to the left of a is a 2a, and these a's cancel, it's just 1/2. And if we go back up and see if this makes sense, imagine if this b was instead a. That means that this function would only be defined from x is equal to a. So that means this function is only defined at pretty much no point. And the entire wave function is described by this part of the piecewise function here. So that means that the entire right side of this function would go away, and then it would just turn into 0. That means that by integrating from 0 to a, we must get a probability of 1, because this will be the only non-zero portion of the wave function. Integrating anywhere else will give us 0. And then now, if we imagine that b is equal to 2a, if we plug in 2a for b, what we get for this portion of the piecewise function is square root of 3 over b of 2a minus x, and then it will be 2a minus a. But then this is the same as the square root of 3 over b, 2a minus x over a. And if we plot this function out again, what we eventually get is a symmetrical function with respect to a. Because now b will not be this far away from a, but instead it will look something like this, where this is 2a, or this is just b. And this will be symmetrical with respect to a. So that means that if we were to integrate this function on the left side of a, we must get a probability of just 1/2. Problem 1.4e asks us to find the expectation value of x, and this is equal to the integral from negative infinity to infinity of the complex conjugate of the wave function times x times the wave function dx. So from the interval from 0 to a, it's square root of 3 over b, x over a, x square root of 3 over b, x over a, dx. And then from the interval from a to b, it is the square root of 3 over b, b minus x, b minus a, times x, square root of 3 over b, b minus x, b minus a, dx. And then when we simplify this, we can pull out anything that is not with respect to a. So it will just be 3 over a squared b from the interval from 0 to a of x cubed dx. And now we can do the same thing from the interval from a to b. So pulling out everything that is not with respect to x, we get 3 over b minus a squared times b, and then the interval from a to b of x, b minus x squared dx. So we could evaluate the leftward integral first. it'll just be 3 over a squared b of x to the power of 4 over 4, evaluated from 0 to a. So this would be 3a to the power of 4, a squared b, and then it's just going to be 3a squared over 4b. Now we can integrate the leftward integral. So 3 over b minus a squared b from 0 to b x b minus x squared dx. And in order to simplify this, we could use u substitution. So u is equal to b minus x, du dx is equal to -1, and then x is equal to b minus u. The initial value of u is b minus a, and the final value of u is 0. So we could substitute all these things in. And now we have to split the integral up into 2, since we have to distribute this u squared in. And then now we can integrate both of these. The first integral will turn into bu cubed over 3 from b minus a to 0. And the second integral will turn into u to the power of 4 over 4 from b minus a to 0. We don't need to worry about the zeros since they'll just turn the function to 0. But then now what we get is 3b minus a squared b, and then this will turn into b minus a cubed over 3, and here this will turn into b minus a to the power of 4 over 4. And the reason why the sign switches is because b minus a is on the bottom instead of the top. And now by simplifying more, the first term will be just b minus a, and the second term will be minus 3b minus a squared 4b. And then now we have to go back up and then see that this is what we got for the rightward integral, and then the leftward integral is 3a squared over 4b. So the expectation value of x is 3a squared over 4b plus b minus a minus 3. And now we can factor this, which is b squared minus 2ab plus a squared over 4b. Now we can simplify this further by having the denominator of all these terms to be 4b. So we just have to worry about these two terms here. So it's 3a squared plus 4b squared minus 4ab. And then now we can distribute this 3 in. So negative 3b squared plus 6ab minus 3a squared. And this is all over 4b. So we see that these cancel. And these cancel to just have b squared. And these cancel to just have 2ab. So now it's just b squared plus 2ab over 4b. And to simplify further, we get that it's just b plus 2a over 4, since these b's will cancel out. I hope this video helps. Feel free to leave any questions in the comments.